Hi, welcome to the video series covering the features of the toolbox called HyperWorks LiftShip. In this video, I'll be specifically covering the model section that we have here, the pad application, deletion, support, creation, deletion, spools manager, an RB2, which is our core tool, and generating contacts. If we open up our training model package, you kind of see what stage we're at. If we want to go ahead and drag and drop 4C, this is completed up to this stage of the mesh is basically done. We just need to start adding where different subparts of the model will be, namely the lifting points. So let me go ahead and okay. So we'll start with our pad placement, and here we will either have them automatically imported via the ship constructor database, or we will go ahead and drag and drop those, import those in. So it just so happens that I have placed them myself in this alternative pad placement, and so we have some static ones which can be placed on the top of the structure. Here you can see here. Those would be just if you're going to basically statically lift the model in the Z direction. That was used for LiftShip 1 program. This is kind of the LiftShip 2, where we're doing more of a dynamic rolling type of simulation. So for that, we're going to use this import hypermesh model. And we're going to do these turn. So these will be the pad eyes that I want to use for the following demonstration and training. So what we could do, is just go ahead and select these. And not you. So I'll hold down Shift here and say hide. I'm going to lock the view. And let me switch back to automatic. Gets a little more interesting that way. So now that we have our pad eyes placed for our turning simulation, we want to connect them basically to the structure. And again, I want to mention, it's also highlighted here in the little pop-down help information, the param and criteria file should be loaded. So basically double check if you've loaded a fresh model that you have these loaded before you get started with them. So let's go ahead and go over here, click on param, and it looks like our 40 file has been loaded, and make sure our criteria file is loaded. Okay, good. So that will be used in kind of a couple of these other stages. And so we have this pad eye comps, and what it's going to do is, if I zoom in here, it's going to automatically recognize certain features which are common between these types of pad eyes or lifting lugs. You kind of have this circular cylindrical shape, and then you have this kind of this bottom face. So the algorithm's going to automatically look for those features, and based on that generate a rigid element to attach to the structure. Rigid element was kind of selected for the program just because these pad eyes are typically over-engineered and very stiff compared to what they're mounting to. So the degrees of freedoms can be activated or switched off, and also once this is executed, there's a rebuild operation to help clean up the quality of the mesh automatically. If for some reason that's giving you issue, you can deactivate it here. So we'll go ahead and select our pad eyes just right from the interface. Go ahead and rotate our model here. And then what we want to do is go ahead and select the components that they attach to. Just one more turn here, and then we'll say create rigids. And just give it a moment, and it's going to basically go through a variety of operations. It's going to find that mounting face. It's going to imprint those edges onto the components for attachment, and then it's going to generate a rigid element attached to those kind of nodes that are already on your structure, and generate that rigid element. So it should be just about done here. It'll be clear once it gets done. And then also in the model, if we double click on components, we can go ahead and scroll down here. We note that it created these pad eyes. So let's go ahead and zoom in. You can kind of see where it imprinted. So let's go switch over to our topology view and also bring back our geometry. There we go. If this hover highlighting kind of gets on your nerves, sometimes it does to me, we can go ahead and go to preferences. Oops, hold on, a little too fast for my own good. And there we go, turn off this hover. Apply, okay. All right, so now we can just hover over the model, and so you can see it imprinted, generated that rigid element at where the center of the pad eye would be. We've got a nice little node also to kind of indicate where it's at. Okay, so those are our pad eyes replacement, and then it's also our topology. We could also double check on the element quality, which we'll be getting to next. And in this area, you could see that we have some good quality. There's no results, basically. Go back here. Actually, I'll leave geometry on for the next stage. That's kind of important. So the last kind of item for this pad eye is this little X icon. You can just easily delete it, and it'll bring your solid geometry back. The original geometry is just kind of hidden. Its entity state has been hidden. So let's talk about supporting structure next. So if you already know where you will need some supporting structure, kind of just based on your experience, we can go ahead and start applying that. In running this analysis, we can kind of see that we have some structure that might just be kind of hanging a little bit. We might want to kind of add some temporary supporting structure to that. So let's go ahead and do that. Go ahead and click on our support structure, and we're going to get our support structure browser little tab here. Let's give the first one a name. Support. Maybe we'll call it T1, and we'll go ahead and go through selecting the nodes. You can have very specific locations, or you can just approximate where these will be mounted based on the nodes in the mesh. And then maybe I will attach it to over here. And just to get it initialized, we need to give it a kind of a direction node, this orientation node. Go ahead and click the green checkbox. And then we'll do a T-shape like I mentioned. We will go ahead and select our materials. Just follow along kind of the workflow here. And here we'll have dimensions. Maybe we'll do 80. And then 80 tall. And then maybe we'll do a thickness of 10. And we can do a little preview. So there we can see where our orientation might be. And maybe I want to rotate this, 180 degrees. Here we go. So this will be basically a preview of what it's going to look like. And again, we also have that rebuild mesh around structure as an option. Let's go ahead and hit create. And it's going to basically generate a surface and generate a mesh on that. And going to stitch the model back together. An important note will be to ensure your geometry is displayed when you're doing this process. If you don't have it, you'll get a little friendly pop-up message saying please display your surfaces. It's just a necessary step for the algorithm. Alright, so once we have our supporting structure in place, we can move on to the next one. So let's go ahead and do one more. So I'll call this one T2. And we'll go back to maybe we'll go over here, go to this guy. Go and select that node, go and select that node, select the orientation node, and this time we'll do maybe a L shape. Go and select our material, and this time we'll have a dim one. We'll do 110, dim 2, maybe 80, and then keep the thickness. Go and click preview. And it looks about right. We'll go ahead and create. again, from an organizational perspective, those are creating brand new components. And at any stage, if it doesn't look right, or if we want to move it, we can just simply go ahead and click on that component and say delete. And it'll remove it and rebuild the mesh. So, okay, great. Now that we have generated our supporting structure, again, you could always come back and rebuild that at another time after you've run a baseline simulation as well. The next one is the spools manager. We didn't utilize this so much for this portion of the program. So the LiftShip toolbox was developed. This LiftShip toolbox was developed in the LiftShip 2 program. But basically what you're able to do is import a .tsv file, which also comes from Ship Constructor, and it's going to load in basically spool names that the design engineers has generated, which represents concentrated masses. You'll have your names, you'll have the XYZ location, mass, and so forth. But two tools that were added to the spools manager, which were requested, was to be able to convert geometry to concentrated masses, and also to do what we call mass trimming. So if you want to apply mass to a certain portion of the model via the nodes or the elements, you could do that here. So this is, basically an automation script, and then this is a browser that is core to HyperWorks. So you could find more of this in our documentation, but it isn't covered here in the util 1 example. Something else we included in this workflow of tools was just the core RB2 or RB3, depending if you want to rigidly attach something or to kind of flexibly attach it. So again, those are core features which just kind of make this workflow more user-friendly. And then last but not least, just to make sure we don't have parts just kind of flapping and flying off in space, we included the contact browser, which is the core tool. I'm just going to use the auto, and I'm going to tie any of the components together that may not have, may be connected in reality, but not connected yet. So, for example, let me see if we zoom in here, if I can find those parts. Yes, right here. So you see these parts here. Maybe easier if I just said only geometry. We could toggle this. Here you can see these. So these kind of like brackets here are mounted, but they are not, touching this kind of stiffeners, this kind of red and blue stiffener. So what we might want to do is generate, kind of a general contact between these two parts just to add a little bit of stiffness. Something else that we're investigating to automate is weld generation. So that could also be done, but isn't included in this toolbox. That could be covered via the connectors workflows. So if that is of an interest, I'd be more than happy to put together another video for that as needed. So let me just kind of clean up the GUI here a little bit, bring back my elements, and we'll go back to our little lightning bolt. This doesn't take too much time. Go ahead and click Find. Again, this is the core tool. And I like to, you could scroll through this if you want, it doesn't mean a whole lot to me if the model's too big, so I just usually accept it, and I will go ahead and go into the contact manager. You can go ahead and hit Control A and hit Q, and then we can do a quick little preview of all those contacts that got generated. So in general, again, you're just trying to make sure that you tie all those parts together. And with that, that'll conclude this video, kind of summarizing the steps of the model section. I hope you found it helpful. Please leave us feedback on our Altair community forums.